So these are the 10.3 notes for solving rational equations. Let's start with a math review. We want to factor x squared minus 7x minus 44. So we're going to look for two numbers that multiply to make negative 44 and add to make negative 7. So numbers that multiply to make 44, we're going to have 11 and 4. And since we want it to sum up to negative 7, we're going to make the 11 negative, right? So our factors are going to be x minus 11 and x plus 4. For the difference of squares, we're going to look for which quantities we have to square to get each of these terms. So 25 is, of course, going to be 5 squared, and 4x squared is 2x squared, because 2x times 2x is going to give you 4x squared. Once we have these two terms, we can find the two factors to be the sum of them, and that the other one will be the difference. Adding and subtracting fractions. So these have different denominators. We have a denominator of 7 and 8. So their common denominator is going to be the first number that you'll find in both of their times tables. In this case, it's going to be 56, which is 7 times 8. So I'm going to make new fractions with the denominator of 56. To do that, I'm going to multiply this one by 8 over 8, and this one by 7 over 7. This is going to give me 48 from 8 times 6 over 56. This is going to give me 21 over 56. Now subtract 48 minus 21. That is 27. And the denominator is 56. And that does not reduce. And now solving for x, I'm going to distribute 2/3. We're going to get 4x from the 2/3 of 6x. And we're going to get 8 from 2/3 of 12. I did not change the right side. I'm going to subtract 8 to isolate our x's. We have 4x equals 7. Isolate x by dividing by 4. We have x equals 7 over 4. Or 1 3/4, if you prefer. Okay, so solving rational equations using cross multiplication. This allows us to turn something like this. Well, we've got a fraction here, a rational equation, right? A fraction here that has x's, and we can turn it into one of these. We know how to solve these, so from there we can find the value of x. So when we have a fraction equals a fraction, we're going to cross multiply, right? Now what's going on here is I'm going to multiply both sides by 4x. That will clear the 4x from here, and we'll put a 4x over there. And then I'm going to multiply both sides by 3. That will clear the 3 here, but it's going to multiply this side by 3. So that's what's really going on when we cross multiply. Right? So 3 times 2x plus 4. The denominator of this side times the numerator of that side. And then the reverse. So this one times this one. That's just 4x. I'm going to distribute the 3. And we can collect up the x's. I'm going to do it like this way, I guess. Alright, so we have 12 equals negative 2x. And then we divide. So x equals negative 6. For this one, I'm going to do the same thing. Alright, so that's going to be 5. And that's going to be x minus 4 times x. So after I distribute this x, we're going to have 5 equals, and we're going to have x squared, and we're going to have minus 4x. With a situation like this, so we've got a squared term, so we've got a quadratic, and a way that we know how to solve quadratics is to set them equal to 0 and find the roots. So to set it equal to 0, I'm going to subtract 5. from both sides. And now I can factor this. So 0 still equals. We want the two numbers that multiply to make negative 5 and add to make negative 4. Those are going to be negative 5 and positive 1. Now that we have 0 equals two factors multiplied together, we will say 0 equals each of the factors individually. So if 0 equals x minus 5, x equals 5, and if 0 equals x plus 1, x equals negative 1. So those are our two answers. Another cross multiply, we're going to have 3 times n plus 2 equals 1 times n plus 6. Distribute the 3, so the n plus 3 times 2 is 6. And then let's collect up all of the different types of terms. I'm going to subtract 6 from both sides. Now we have 3n equals n. Kind of odd. Some students did not know what to do with this. In this case, we're still just going to collect everything up. Right? So I'm going to move all the n to the left side by subtracting n. We have 2n equals 0. And now we can just divide by 2 to get the value of an n. And n is going to equal, well, what's 0 divided by 2? This is saying how many times does 2 go into 0? It doesn't go in any times. It's still 0. Right? So the answer is n equals 0. So there will be a couple questions like this on the test. Determine whether the given value is a solution of the equation. What this is saying is, we've got an equation here, and someone has apparently found the answer, but they want to know if it's right or not, right? They're asking, is it a solution to the given equation? Why or why not? In this case, 2. So to do this, what we do is we should replace all of the x's. We substitute x for, in this case, 2. So that'll give us 3 times 2, coming from 3x. And then we have x plus 3, so x equals 2, so I guess that can be 2 plus 3. And then on the other side, we have 6. And then we have 2 plus 3 down here as well. Now in this case, we have 6 over 5 equals 6 over 5, right? Since this is true, we're going to get the same stuff on both sides. Yes, that is solution. And it's because we got the true statement. But the next one we have, is x equals negative 4 solution to this given equation? Why or why not? So we're going to replace all of the x's with negative 4. Now rather quickly you should see a problem. But continuing on for a moment, I will still replace all of the x's with negative 4. In this case, we have negative 4 plus 4 in the denominators of both of these fractions. Now what does that equal? That equals 0. And we are not allowed to have 0 in the denominator of the fraction. It's undefined. So, no. This equation is not defined at x equals negative 4. That's because the equation equals undefined at negative 4. Now what about when we have a situation like these, where we don't just have a fraction equals another fraction? Here we have two fractions being added together equals one fraction. Use a different method for these. We will first reject any extraneous solutions from the final answer. Extraneous solutions are solutions that don't satisfy the original form of the equation because they produce untrue statements or excluded values that make the denominator equal to 0. That's a lot of words to say. There's just some things that we know cannot be the answer by looking at the function at a glance. So starting with this example, we have to look at our denominators. We have a 3, a 5, and a 15. Since there's no variables there, no x's in the denominators. There's no values of x that would put a 0 down there, right? The 3, the 5, the 15, they're unchanging. So this one will not have any extraneous solutions. So to solve, we're going to find a common denominator. Here we have 3, we have 5, and we have 15. Now 15 is, of course, 5 times 3, right? So this is saying this has the factors 5 and 3 down here. This one only has the 5. This one only has the 3. In order to make everything be the same, I will multiply this one by 5 over 5, and this one by 3 over 3. So that's going to give me 5x over 15 plus 6 over 15 equals 21 over 15. Again, I don't have to change this one because it already has 5 and 3. Now in this case, now that we have everything having 15 on the bottom, I will just multiply both sides by 15, right? Because I can do it to both sides. This allows me to remove all the 15s, and we have 5x plus 6 equals 21. Solve this rather easily by subtracting 6. We have 5x equals 15, and then we divide by 5. 15 divided by 5 is 3. Here we have 5, an A, 10, and an A. Now 10 is, of course, 2 times 5. So every denominator is going to need 2, 5, and an A. That's all the distinct factors I see. So this one has 5. It's going to need 2 and A. This one has A. It's going to need 2 and 5, which make 10. So I'm just going to write the 10. This one has 10. It's going to need an A. This one has an A. It's going to need 2 and 5, just like this one did. So we get new fractions. Now we have 2A over 10A. We have 40 over 10A. We have A over 10A, and we have, this last one is 70 over 10A. Now that they're all over 10A, I can just cross them all out. Oh, right, and before we did that, checking for the extraneous solutions again. So what values of A would put 0 down here? Since the A is not being modified in any way, we know A cannot equal 0, because that would put zeros in the denominator of these fractions. Okay, so from here, I got rid of the denominators. We have 2A plus 40 equals A plus 70. We can subtract A and 40 from both sides. So we'll have A equals 30. That's going to be the answer. And that's not, so the only extraneous solution we found is A would equal 0. That would be extraneous. We didn't get that, so that is the answer, and it's not extraneous. We keep it. For this one, look to the factors once more. This one has x and x plus 2. This one has x. This one has x plus 2. Now x plus 2 is a whole factor on its own. We cannot separate variables connected to a number by a plus or minus. We can't separate them like that. So we can't just say, oh, this one needs plus 2, because we can't just add to the top and bottom. That does not preserve the equality of the fraction. We're allowed to multiply because we multiply the same thing on the top. That's the same as multiplying by 1, which of course does not change the value of a number. So since we can't add, to make everything have the same denominator, I'm going to multiply by what each one lacks. This one has x and x plus 2. This has x plus 2. It doesn't have an x on its own. This has x. It does not have x plus 2. So our new fractions are x squared, 4 times x plus 2, and then I didn't change this, 28 plus 3x over x times x plus 2. So what are the extraneous solutions? What would put 0 down here? This one, we can't have a 0 on its own, of course, because that would put a 0 here. cannot equal 0. And to get 0 here, the value negative 2 would give us 0, because negative 2 plus 2 is 0. So x cannot equal these two values. So let's solve this. They're all the same on the bottom. I can cross those out. And then I'm going to distribute this 4. And then I can gather up all of the terms on the left side. And by turning this into a quadratic that equals 0. So we have x squared plus x minus 20. Now to factor this, numbers that add up to 1 and multiply to make negative 20. Well, we know 5 and 4 multiply to make 20. And which one's going to be positive? Again, because we want the negative is going to come from 1 being positive and 1 being negative. Since it needs to be a positive sum, it's going to be 5. So x plus 5 times x minus 4. Right? And then just like with the previous one that was like this, we set each of these equal to 0. So the values here, if x plus 5 equals 0, subtract 5 from both sides, we get x equals negative 5. And then if x minus 4 equals 0, add 4 to both sides, we have x equals 4. And neither of these are extraneous, because again, these would be the extraneous solutions, but they don't equal those. So both of these are fine. Now we have some real-world situations, some word problems. There's some questions on the test just like this. The formula you want to know is that you'll have the speed of one plus the speed of the other equals the speed of them working together. So let's read. A large biotech firm uses 2 computers to process the daily results of its research study. One computer can process the data in 2 hours. The other computer takes 3 hours to do the same job. How long would it take to process the data if both computers were used? So we've been given the speed of both computers. What we want to know is the speed of them working together. The speed of the first computer is I guess our units here are jobs. It does 1 job in 2 hours. Right? So that's the first computer speed. The second computer has a speed of 1 job per 3 hours. Them working together, so the speed of them doing 1 job together is going to be 1 job in, we don't know, x hours, right? So it's our variable. Now we have a problem like this. So let's find the common denominator. I just labeled my units. Of course, the hours and the jobs, those are not factors, they're not variables, I just labeled the units. So we have a 2, 3, and an x. So this one doesn't have 3, and it doesn't have x. This one doesn't have 2x. And this one doesn't have 2 or 3, so it needs 6. Because 2 times 3 is 6. So our new fractions, we have 3x over 6x. And we have 5x. Sorry, no, we have 2x. Got hasty there, added it already. 2x over 6x. And we have 6 over 6x. Now they're all over 6x, get rid of them. And we have 3x plus 2x equals 6. So 5x, 6, divided by 5. And we get 6 over 5 hours. So that's 1 hour and 1/5 of an hour. And if you think about the reasonableness of that answer, it does make good sense. So we have a computer that's this fast, right? Does it in 2 hours. And another one that is a bit slower. It's about a third slower. If we had 2 that were this fast, we would expect it to be done in 1 hour, right? Because if one of them takes 2 hours, and if we have 2 of them, we can do it twice as fast, get it done in 1 hour. But since this one's a bit slower, time taken will be slightly more than 1 hour, which, yes, it is. Now we have another type of word problem. Very similar, though. Kevin can clean a large aquarium tank in about 7 hours. When Kevin and Laura work together, they can clean the tank in 4 hours. Write and solve a rational equation to determine how long, to the nearest tenth of an hour, it would take Laura to clean the tank if she works by herself. So this time they've given us one speed, Kevin's. He does one job in 7 hours. But we don't know the speed of the second person, right? So that's the variable here. But we do know the speed of them together. So them together, the plus. Now in this case, solve it in basically the same way. Look at our factors. We have 4x and 7. They're all different, don't share anything, so just give everyone what they don't have. Multiply this one by 7x over 7x. Multiply this one by 28, because that's 7 times 4, so not 28x, just 28. And this one by 4x. Right. So now we end with 4x over 28x at 28. And we have 7x over 28x. Now they're all over 28x, so I get rid of these. I will subtract 4x. And then I'll divide by 3. So x equals 28 over 3, which is 9 and then a third. What's a third as a decimal? Going to be 0.3. 9.3 hours. Finally, we have it takes Brad 2 hours to mow his lawn. It takes Chris 3 hours to mow the same lawn. At the same pace, how long would it take them to mow the lawn if they do the job together? So, we have both speeds. Remember, we have speed 1 plus speed 2 equals speed of together. So in this case, speed 1 is, these are always going to be 1s on the top, because that's how speed is represented. Speed is the inverse of time, so inverse is going to be 1 over. So Brad's speed is 1/2 of a lawn per hour. Chris's speed is 1/3 of a lawn per hour. And then if they work together is the variable. Now if you'll notice, half plus a third equals 1 over x. That's actually the same problem here. Half plus 1/3 equals 1 over x. I'll go ahead and solve it again, just to be sure. Looking at our factors, we have 2, 3, and x. 2 needs 3 and it needs x. 3 needs 2 and x. And then x needs 6. So 3x over 6x, 2x over 6x, and 6 over 6x. Same denominator, 5x equals 6, and thus x equals 6 over 5, which equals 1 1/5. Same answer, same problem, same answer. So that's the choice B.